Yeah. Hi, good evening, everyone, and thanks for joining this revision session for the Quiz 1 for the reinforcement learning course of IIT Madras PS program. And agenda for today is basically we will go through the important concepts of week 1 to 4, and thereafter we will see some important questions of PYQs. So already I have shared the all the solutions of PYQs. So maybe in this session we will not be able to go through all of them, but after this session can go through all the PYQs, and in case of any doubt, you can post in G Space or on the WhatsApp group to discuss that. So with that background, let's start. Am I audible? Can somebody give me a hand?
Yes, you are audible. Yeah.
Yeah, thank you so much. Yeah, okay, I'll just share my screen, and my pace will be slightly faster because we have got 4 weeks to cover. Okay, so with that background, I hope my screen is visible to all of you.
Yes, visible.
Yeah, very nice. Thank you. Thank you so much. Yeah. So I'll just go through the important concepts from revision point of view for the quiz. So starting from week 1. So week 1, the first important concept which came was the immediate reinforcement. Immediate reinforcement means that we take a step and we get a reward immediately. So in that, we always face a dilemma known as explore or exploit dilemma. And it means, when to stop exploration before I exploit, you know. And so it has got all the pros and cons. So there are many problems for which we cannot keep on exploring. Maybe we will get a solution after 2 days, but we need to exploit it within maybe next 1 hour. For example, showing the news on a news portal. Now, after 1 hour, that news might become old. So that is a case where we have to start exploring and exploiting. And similarly, when to stop exploiting and start exploring, because maybe we have not found the correct solution, we have not found the best arm. So that is a dilemma. So that is the understanding of explore exploit dilemma. Now coming to the multi-arm bandit, the update rule is qk plus 1. That is the your update which is there is will be qk plus 1 by k. So in our lectures, it was covered 1 over k plus 1. But if you see all the standard reinforcement learning material, it is covered there as 1 by n, that the nth step. Now remember this k which is there, it is for that particular arm. It is not the total number of selections. Okay, for example, there were 10 arms, and this arm which is there, qi, I have selected only 3 times, then k becomes 3 for that. And this is qk plus 1 by k, rk plus 1, that is the reward which we have got, minus the previous reward and divided by this. So this is k starts from 0. There are many questions in PYQs based on that. And it is will also be used in other questions also. Now, E greedy was that when we become epsilon greedy, if we use only this qk plus 1 is equal to qk plus 1 by k, so what will happen? We'll always keep on selecting an arm which has got the maximum reward, and we will not be able to explore. So we have to explore. So for that, E greedy algorithm is there. E greedy means that we will select the arm with the maximum reward till now with 1 minus E plus E by k. So this is an important formula. It has not been covered in our lectures. 1 minus E plus E by K, where K is the number of arms probability. And other arms will be selected with E by K, where K is the number of arms. So just to give you an example, if epsilon is 0.1, then the number of arms is 4, then best arm will be selected 1 minus E, that is 0.1, plus E by K, that is 0.1 by 4. So it will come 0.9 plus 0.025, which is 0.925. And what does it mean? That around 92.5% of the times, we will select the best arm. And rest other times 7.5%, which is 0.1, that is E by K. And how many arms are there? 3 arms. So 7.5% times we will be selecting not the best arm. So that's how the exploration happens. So please remember this formula. Now, next is that, for example, if we select, for example, if we select the probability as per the reward functions, then it cannot handle 0 values because it will become 0. So for that, we have softmax, and softmax is a temperature. This is the parameter tau. It is the temperature. So probability of selecting an arm will depend upon the exponential of qi over tau divided by summation of eqi over tau. Now, when this tau becomes large, so you will realize that this value will become same for all the arms. So it means I will have same probability to select any arm. So this is the effect of tau. But if tau becomes very less, then it will be able to distinguish between the arms with similar reward. For example, one arm has got reward of 42, another arm has got 44. Now, if I make this tau very, very small, for example, 0.01, then it will give the probabilities, the difference in the probabilities will be high. That's the basic effect of tau. Now, the next algorithm is UCB. In the UCB, how we select that? So there's a error here. This C will go inside. So the formula is Qi is equal to Qi plus under root C. C is a parameter. C is a parameter, hyperparameter, I can say. Parameter. And natural log of T. T is the total number of steps. T is total number of steps divided by n. N is the number of steps this has been chosen. Number of steps for ith arm. Okay. So if you consider this, if you take this part, this is known as the confidence part. Now for any arm, as the n increases, so n is in denominator, this entire term will decrease. It means your confidence which is there, confidence is increasing. And remember that with the t, this value when it changes, it will change for all other arms also because t is changing. With every step, t is changing. So for that, qi will change for all other arms also. The next was probably approximate correct case, where the probability that whatever the mean you have found and the difference between the actual mean, the absolute value, has, if it is less than epsilon, then it will always be greater than equal to 1 minus delta. So this is the formula. This has come in 2 PYQs. This has come. So this is at least 1 minus delta. So this is the PSE.
So what is delta?
Delta is we say confidence interval. For example, if a delta is, for example, 0.1, okay, and epsilon is, for example, 0.1. So I can say that the mean which I found, it is the within that 0.1, and my probability which is there, it is more than 90%. Okay.
Yes,
If you think the statistics 2 course, so there we used to use this delta. Okay, so this is the probability which is giving to us that my probability that my mean which I found, it is not deviating from the actual mean by 0.1 with 90% of the
yes,
confidence. Yeah. Okay. Then there is a something called lin UCB. In lin UCB, what happens? The predicted award. This is a linear UCB. The predicted award is considered, it is linearly correlated with some features. So what we do, we find the weights or the parameters for these features using Ridge regression. And then after that, we find upper bound of confidence interval. There has not been a single question on this. Just understand this basic concept that in the lin UCB, we have got the ridge regression. We are trying to find the weights. And these features are correlated with the predicted award. And once we find the upper bound of confidence interval, we use the UCB. So I'll share this note. I have given a small example for lin UCB. You can go through that. It is self-explanatory. I'll not be doing that. So with this, I have finished week 1. Any question in week 1 concepts?
So will you be able to share this notes with us? Is it
Yes,
possible?
yes. I will immediately after this session. I will share with all of you.
Thank you.
Yeah. Okay. Now, shall we come to week 2?
Yes, sure.
Yeah. Okay, so week two starts. Okay, the main concepts again I will be covering. I will not cover the entire content. So main content is number one is the Markov property. Property, what it says that your probability of being in some state, for example, in the next state and some next reward, does not depend on your entire history. It depends only on your present state and the present action. So it means the probability of ST plus 1 and RT plus 1, and it does not depend on your R0, A0, S0 till now. It will depend only on ST and AT. That is the Markov property. What is the MDP? MDP is written as SAPR, where S is the set of all states, A is all actions, P is the policy. Policy means that in this state, what action I will take. This policy can be deterministic also. For example, if I'm in a state is hot, and I will say I will move right only, then it is deterministic. It can be stochastic also. If it says that I'm in a state hot, I will go right with the probability 0.5 and I will go left with the probability of 0.5, then it is known as a stochastic probability. R is the reward. So R is always written as S, what is the present state, A, what is my action, and what is my S prime, because S prime in stochastic policy, it may be different. Like from hot, I can go to left, I can go to right, and I will land up in some different next states. So always R is written as SA S prime. Now, if for returns with terminal state, where we have got a terminal state well defined, then the return is just the sum of all returns, RT plus 1, RT plus 2 up to RT, where this return is of terminal state. Return at terminal state, always remember, is 0. Or it can be given in the question also, but value function is 0. Now, if you consider in this, there is nothing, we have changed gamma is equal to 1. Okay. Now, for continuing task, where there is no terminal state, GT is equal to RT plus 1 plus gamma into RT plus 2 plus gamma square RT plus 3, and it keeps on going. Now, when we have got a terminal state, remember this gamma becomes 1 and we have got a terminal state. That is the only difference. I will encourage all of you to go through the geometric progression formula, because in PYQs, you'll be using those calculations to find this GT. So how we do that? I have solved that in PYQ, so you can go through that. It is very, very easy, nothing, no rocket science. Now, these next two parts which are there, they are very, very important. Please understand very, very carefully. Value function of a pi in a state. So this V pi S is means that there are various states, and I am finding value function in that state as per that policy. So what is that? Now, as per that policy, first of all, I can have, if it is a stochastic policy, I can have various actions under that state. So I have to cover all the actions, summation of pi A over S. Then I have to do summation of probability S dash over SA, that I was in state A, I took some action, I landed up in S prime, into what was the reward which I got, SA at S, plus gamma into V function of following same policy in the next state. Okay, so this please remember. Now for a deterministic policy, this V pi over A over S is deterministic. So we can remove this. So for a deterministic, this just becomes V pi S is equal to P of S dash over SA this. Now Q pi S over A is that at the first step, I will take action A and thereafter I will follow the policy. So that is the meaning of Q pi SA. So if you consider this both of them, then we can write V pi over S is nothing Q pi, this pi over A over S into Q pi S over A. Okay. And for deterministic policies, like I said, this Q pi A over S is not required in here, and V pi over S becomes Q pi over S over A. So these three things are very, very important to understand, not only to memorize. Okay, any question till now here?
So is this because like so that same page? Can you hello?
Yeah, just give me 30 seconds. Yes, tell me.
So the sixth point and fifth point, sir, the policy we are removing and we are equating v pi of s is equal to q pi of s. Is it because the policy when we take the summation of policy, then if the policy is like if it goes to the north, south, west, and east, then it cover all the directions, so it sums up to one. Is it so?
No. So I will just cover it here. For example, I'll just give you one example. We have got this quadrangle. This is terminal state. This is 1, this is 2, this is 3. State is 1, 2, 3, 4. Actions are north, south, east, west. Now there can be two policies. Deterministic policy, for example, will look like in 1 I will go east only. In 2 I will go north only. Okay, just start button. East over 1, north over 2, north over 3. So this is a deterministic policy. Okay. Now, for example, with this, try to find the value function. Try to calculate value functions. V pi of s. So V pi of 1 will become, now see, I don't have any other action, so I don't have to do P pi over A over S. This is not required because there is only one action.
Yes, sir. Yes, sir.
Okay, that's why in the deterministic we don't consider this. So this will become only what is probability of S dash over A over S. S dash is what? 4 if I go east. So this is 1 and 2 R of S A S dash plus gamma of V pi of S dash. Now we know R, for example, we say for terminal state is always 0.
Yes, sir. Terminal is always zero.
So this becomes 0 and this V pi S dash is also 0.
Sir, wait a
Okay,
second.
sorry.
V5 is terminal, na? So
Yeah. So reward is, for example, every step we say, every step reward is equal to -1. Okay. So this will become -1 plus 0.
yes, sir.
So here I get -1. Okay. Similarly, I will get -1 here. And here I will get -2. And it is the optimal policy. Okay. And
Yes,
how many policies I have got in this MDP? I can go like this. I can go like this.
yes.
There are two policies.
And so
Now,
diagonally we can't go
no, diagonally is not allowed. Only north, south, east, west.
interest. Okay, sir. Actions. Okay.
Yeah. Now, for example, if I will make it as stochastic, I take same example, 1, 2, 3, 3 and 4. This is terminal. And now policy is that north over 1 probability is equal to 0.25 is equal to probability south over 1 is equal to probability east over 1 is equal to probability west over 1. Okay. Now we have to find V pi 1. So this will become, now if I go north, I will get 0.25 into state. What will be my reward? -1 plus V pi of 1 north
Plus
plus 0.25 into -5 V pi over 1. This is west
plus. Yes, sir.
Plus,
I got it, sir.
okay. Now here what will happen? We will get Bellman equations. Okay.
Yes, sir.
So here for all, we will get Bellman equations and we will solve those Bellman equations. So here what we have done, we are considering pi over A over S because it is a stochastic. Okay.
Yes, sir.
Okay. So yeah. So that's why if you consider here, that's why I've written that for deterministic V pi star or this V pi which is there, V pi of S is equal to Q pi S over A for deterministic because there is no pi A over S. Okay. So remember these things. Now we come to week 3. So week 3 is the continuation from here only. The same formula has been used V pi over A over S. Now when you use this for all value functions, so these are linear equations in S number. So if there are 4 states, I will get 4 linear equations and it can be solved. We know mathematically. Now V pi star of S. V pi of a star means that what is the best value function? What is the maximum value function I'm getting by a policy? That is my V pi star. So in this example, we can see that we got the best here. But when we will do stochastically, you will realize that you will get, but you might have to iterate every time. So V pi star, this is a simple example. So every time you will get here, but V pi star is the value function of the best policy which we have found. That gives the max value function given by a policy. Now remember, in an MDP, we can have various optimal policies like we saw here. We saw here there are 2 optimal policies. But remember, value functions for all the optimal policies will be same. Like for example, here for both the policies at 3, we have got -1. Here we have got -2. Here we have got -1. Another important concept which I will cover here, that pi 1 is greater than equal to pi 2 if and only if value function of pi 1 is greater than equal to pi 2 in all states. All states. Then only we can say that pi 1 is or pi 1 is equal to pi 2, then means V pi 1 of S is equal to V pi 2 of S in all states. Okay. If in any one state, if does not fulfill, then this will be incorrect statement. I hope that is clear.
Yes, sir. Sir, I have a doubt in the difference between policy iteration and value iteration.
We are coming. We are coming to that. Okay, we are going sequentially. Okay. Now, please remember these formulas because these formulas will come in, multiple MSQs. So we have found V pi star. We have also found that in all optimal policies, V pi star will be same. Now remember, for an MDP, we can have many optimal policies, but it is guaranteed that we will have at least one deterministic policy. Remember this statement. Okay. For any MDP, we can have many optimal policies, out of which there can be many stochastic policies also. But we will have definitely one deterministic policy. That. Now, similarly, Q star pi S over A is max over pi Q SA. Or, so this, remember, this formula Q star policy SA is maximum QS over A, that the policy which is finding the maximum Q value, that will be the Q star. Now, like we had said earlier, for deterministic, V star pi S is equal to max over A, Q star pi S over A. This is nothing. Then how do we find the policy? policy in a state, best policy. What we do the argmax over A, that the A which is maximizing the Q star, that is the best policy for me. Okay, now we'll come to your question, policy iteration. And so what do we do in policy iteration? Policy iteration consists of two steps. One is called evaluation, second is called improvement. In evaluation, what happens? We have got one policy that can be deterministic, that can be stochastic. Now, what we do, we find a value function for that policy for all the states. So what do? We keep on finding the value functions for all the states. And when the new value function is not changing by delta, then we stop. It means there are many number of iterations which we are doing to find the value function for that policy. The second is improvement. Improvement means now I have found a value function. Now I become greedy with respect to that. Okay. Now I will go only greedy. And in that, remember a very, very important thing, that when you are greedy, then you have to be very, very consistent in case there are ties. For example, I am at 1. I'll just give you an example here. Only here. I have found one value function. Here it is -2. Here it is -2. I am at -3. So where should I move? I have to be greedy. Greedy means I can move here also, I can move here also. But I have to consistently break ties. Break ties. And what does it mean? I make a rule that in case of tie, I will move north only. So I will get here. I will not consider this action. Okay. So when I do this, I will get a new policy. Now, when I get a new policy, again, I will do the evaluation. So finding this new policy, I got policy, I go here. I do again evaluation of the value functions. Again, I come here. Again, I go here. Again, I come here. So what I'm doing, I'm evaluating value function. I'm improving and finding a new policy in the policy iteration. The value iteration, what it does, in the value iteration, instead of finding the value function, I find the value function of max over A. I find the action. So here what I was doing this step here. Okay. But I'm doing this max over A here only. So in this, in one step, I am finding the action. And then as per that, I'm finding the value functions. So we can say that value iteration is a combination of evaluation plus improvement in one single step. And we keep on finding these value functions unless they don't change by delta. And here, the policy is found at the last. So we have done all this. And then when this does not step, then we do the policy find. So remember the differences. Here I'm doing this evaluation in many iterations. Here I'm doing only in one step. Here after evaluation, I do improvement and find a new policy, go back. Here I keep on doing that. When my algorithm stops, then only I find the policy. These are the differences. Yes, now you can ask me your doubt.
So, sir, which one is the better one? Because both seems to be same only logically.
No, logically, they both are very, very different. If you consider the time, compute, the value iteration takes much, much lesser.
Okay.
Okay.
So,
Much,
in
much.
terms of the algorithm, both are doing the same thing now. Like, I
No,
was confused.
no. Again, I will cover here. Okay. Just hold on. I'll just give you an example. This is your a problem. S is equal to policy 1 by 4 for all actions. Okay. Reward -1 for all single step. Value. So what we do in the, for example, policy iteration. Policy iteration. I take a random policy first. For example, I say I will go only north. Okay. For example, this is one policy. Now, as per this policy, I will find the value functions for all V1, V2, V4, V5, V6, V7, V8, V9. I will keep on iterating this till the time my V prime 1 minus V1 is less than delta. Is that okay? So I'm doing lot of iterations and I have found value functions. So for example, I have found value functions here. I found here -4, -6, -8, -10, -5, -7, -6, and here -9. For example, these I have found. Now what I will do improvement. Improvement now, I will find a policy, new policy, by being greedy. And I have said that in case of any tie, for example, here there is no tie. So see, if I have to become greedy from here, where I will go? I will go here. I will go here.
Yes, sir, because it
Please.
is rewarded.
So,
Yes.
so policy will become north over -10. From here, I will go here. It will become north over -8. From here, I will go here. It will become east over -6.
4. -4, sir.
-6. From -6, I am going east.
Yes, sir. Okay, sir.
Okay. And then I will go east. So I don't write the like this. I will write, these are not written like this. Sorry, my mistake. So I will write policy is north over 7, north over 4, east over 1, east over 2. Now what will happen from -9? I will go here. So east over 8. From here I go here. East over 9. From here I will go here. East over 5. And east over -2. East over 2. And north over 6. Is this okay? So this is my new policy by being greedy. Now, what I will do, now again with this policy, again I will start. So again,
Value functions for all.
yes, now I will forget this -6, -4, -8, -7, -5 and all that. So again I will initialize them as 0. Again I will do the value function. And I will keep on doing unless I get new value which is less than delta. As I keep on doing this, I will converge. Okay. Where my this policy convergence means my new policy will be similar to old policy. This means the convergence
Yeah, no improvement for the
policy. So this is your policy iteration. Whereas in your value iteration, what happens? Here, what I was considering all actions for all the states that I'll go north, south, east, west also. But here I will consider only the actions which give me best award. So consider I'm at 2, which action I will consider? Only east. Okay. I'm at 1, I will consider only east. I'm at 3, for example, this is 3, this is 4. At 4, I will consider north only. At 5, again I have to break the ties. At 5, I will, no, 5 also east.
5 is east.
Okay. 6 is north. So I will, in this, in the value iteration, I'm not doing the iterations like this, that I'm trying to find values. So I am in one go, I'm doing both evaluation also, improvement also. And when I keep on doing this, when my values, they become less than delta, the new, I stop. So whatever values now I get, and I find the policy. So consider compute and time in value iteration is less. Is okay?
Yes, sir. Thank you, sir. Got it.
Yeah, yeah. Okay. So this is one. So in the PYQ, please go through the questions. There are a lot of questions on the calculations. Remember, in the value iteration, initially we gave all the values functions as 0, that all the values are 0, and then we calculate. Okay. Then some understanding synchronous update. In synchronous, we keep two values of the value functions. Asynchronous, we keep only one copy. Real-time dynamic programming. Real-time dynamic programming. See, in dynamic programming, what is happening? We are keeping all the value functions. In real-time DP, we don't do that. What do? We select some trajectories, one or two, and we will update only those value functions in that iteration. And we keep on doing, it will converge, provided we have visited all the states and we have taken all the actions. Monte Carlo, first visit, all visits, it is very, very easy. GPA, generalized policy iterations, is very, very easy. So now after this, I have shared all the solutions of PYQs. I've written all the notes, everything. You can go through that. And in case of any doubt, please pipe up on the WhatsApp group. I will answer that. And with that, I have finished. If there is any question, please ask me.
So one question, silly one, sir. Like time duration is very short, and I haven't prepared much, so I need some passing marks. So which topic should I focus on more?
So I will say, if you go through this document, if you solve all of them, I can assure you will get 80%.
80.
Yeah.
Sir, I rarely get 80, sir.
So you have to increase your pace slightly. It is mathematics heavy, but maths is not like maths for GenAI. The maths is basically class 10th, class 11th. Okay.
Yes, sir.
Understand the concepts. I have covered all the concepts. Concepts are very, very easy. You go through this document, I'm telling you. And in case you are not understanding some part, just pipe up on the WhatsApp group. We'll discuss that. And I can assure you, if you do this, easily you can go through that. Okay.
Okay, sir.
Thank you so much for the session.
Yeah. Yeah. Shyam, thanks for joining in. Have a nice day. Bye-bye.
Thank you. Bye.
All the best, sir.
Thank you to you also.
I hope you'll share the notes. Thank you.
Yes, yes. I'll share the notes in the WhatsApp group also, in the G space also.
Yes. Thank you.